This video is on quadratic inequalities. Okay, these look pretty scary. So when you look at this, it says this is the expression that's greater than zero. So when is this true? That's what this is generally asking. For what values of x makes this product of these expressions true? And this is a very hard thing to just kind of see. And actually, so let's think about this real quick. What if we made x -1, then this part of the expression would be 0. And then we know the whole product is 0 because 0 times anything is 0. So you see that if we have a 0 in one of these expressions, then we get a 0 on the left-hand side. And then the inequality is not true because 0 is not greater than 0. So what would the value be on this side? Well, you can kind of see this. You can let's figure out what makes this 4x minus 2 0. So 4x minus 2 equals 0. Well, if you solve for x, you can quickly see 4x equals 2 and x equals 2. Or x equals, sorry, 1/2. That's my bad. So you can see that when x is 1/2, that makes 4 halves. That's 2 minus 2, and that's 0. And so we get the whole thing is not true if that's 1/2. And we said right here, if x plus, we do the same thing with x plus 1 equals 0. Well, clearly that's x equals -1. It's just one step there. So, what we said is if x equals -1, or if x equals 1/2, then that makes this whole thing 0. And so those are the points you're going to want to find first. Those are called, those are inflection points, right? They're important points that we have to test. And so I made this number line here. Let's try to pull this up. Okay, so we basically have a few regions. We have region A, which is everything from -infinity all the way to -1, right? Our values for x were -1 and 1/2. So we're going to draw those on the number line, and it breaks it into 3 regions. And we're going to test each region for whether that the inequality is true or not. And I'll show you a graphical representation of this too, and hopefully that'll explain things. But this is our method, where we find these important points where it makes the equation 0, or the inequality 0, and then we plot these numbers on a number line, and so we test each one of these. And so region A is everything less than -1, and you can choose any number, -2, -3, -100, and you plug it in for x. You go back to our 4x minus 2 times x plus 1, and you plug in for x and see if it's true. So in this case, we're going to test -2. Well, what do we get? Our equation is 4x minus 2 times x plus 1 strictly greater than 0. So if x is -2, you get 4 times -2, that's -8 minus 2. And here we get -2 plus 1, strictly greater than 0. So this -8 minus 2, that's -10. And then that's multiplied by -1. And so that's greater than 0. And you get 10 is greater than 0, which is true. So we know that any value of x, so what this says is any value of x less than -1 makes this inequality true. And I already have the answer up here, but we're still going to go through this. So we just said any value of x less than -1 makes this true. So that's what we're going to want to look at. And actually, there's only one option here that says that. So we already know that's the answer. So you can stop right there, but we'll also do it for the other value, which is x equals. So we'll look at these other regions, B and C. So the number in region B is 0. So let's test 0 now. So 4 times 0 is 0. 0 here. So we have negative 2 times positive 1. So is negative, that comes out to negative 2, right? So is negative 2 greater than 0? No, that's actually false. So what that tells us is any value you choose between negative 1 and 1/2 does not make this inequality true. Okay, so we'll keep that in mind. And then finally, let's test region C. So anything greater than positive 1/2. So, just pick 2. That's an easy number to work with. And let's look at what 2 does. So that's 4x. So we're going to get 8 minus 2, and then 2 plus 1. And 8 minus 2 is 6 times 3 is greater than 0. And we can already see that's 18. 18 is greater than 0, so that's true. So we know anything above 1/2 makes this inequality true. So we have two regions. We have anything less than negative 1 or anything greater than 1/2, but not here, not in this B area. So that is how we write our answer, is that x is either less than negative 1 or 1/2 is less than x. And any x that meets those criteria will be true. That will make this inequality true. That will make it greater than 0. Okay, so let me show you a quick graphical representation of this. It's pretty interesting. So go to my favorite graphing calculator. Okay. Let's make sure we fit this on the page. Okay. So what did we say? It's 4. Actually, so let's look at y equals 4x minus 2 times x plus 1. Okay, so this is what it looks like. You guys haven't learned parabolas yet, but that is what this is. But this graphs every point. So for any value of x and y, this is the graph. And we actually see where we see these points. See, 1/2, and negative 1. Are those familiar? We just looked at those regions. And so we drew the number line. But if you graph this, you can see that the region in between negative 1 and 1/2, that's below 0 on the x-axis, right? So that's exactly what we were looking at. We were saying, when is x greater than 0? Well, not between negative 1 and 1/2. And you can see everywhere else you get a positive y value, right? So that is x greater than 0 in our problem. And that's a graphical representation. You guys don't need to know that, but I hope maybe it helps you visualize this a little better. And that's it.